We are trying to understand the theory of business, and one of the major objectives of businesses is to maximize total profits. And total profits is a difference between total revenue and total cost. And when the firm tries to, or a business tries to maximize total profits, it tries to either maximize total revenue or minimize total cost, or try both of them at the same time. Now in this video, what we'll examine is the total cost perspective and how can a firm or a business minimize total cost. And as a first step, we'll look at the production function. What we have learned from the previous video is that total cost depends upon total output produced, and total output produced depends on how much labor and capital a firm uses. And what we have been doing is we have been keeping life simple for ourselves. So we assume that a firm needs two inputs to produce output, and it produces one type of output. One of the inputs is labor, which is denoted as L, and all other non-labor inputs, we call them capital or K. And it could be land, it could be machines, it could be raw materials, anything. And so the firm requires two inputs to produce one type of output, and the quantity of output produced is Q. Now, a production function is a physical relationship between output and inputs. And inputs we know are labor and capital, and labor being denoted by L, and K represents all non-labor inputs. When we use the term physical, what we have in mind is non-financial relationship. How many machines, how many workers we require, say, to produce 100 shirts, and things of that nature. And this production function can be represented in a compact fashion like this, where Q is a function which is denoted by F of labor and capital. Now this small f is given to us by engineers or and technologists. They will tell us how many machines and what type of machines we need and how many workers we need to produce, say, certain quantity of shirts or something like that. So this is what a production function is, and the specific amounts of labor and capital required to produce a given level of output is given by technologists or engineers. For example, a production function could be given to us as 5K plus 10L, a specific form of production function. And, and what this is telling us is the following. Suppose K equals L equals 1. How much output will be produced by the firm? It will be 15. When we use 2 units of labor and 2 units of capital, how much output will be produced by the firm? It will be 30. So in this way, this is a very simple example of what a production function may look like, and this information will be given to us by engineers or and technology. Before we examine production function in greater detail, let us distinguish between what we mean by short run and what we mean by long run. Now, in economics, we distinguish this not in terms of months, years, or days. It is simply a time period in which inputs can change or cannot change. In the short run, we assume that at least one input is treated as fixed and the other one can be variable. So, and since we are looking at two input case, we will assume labor is the variable input, and we'll do this all along input, and capital, which is non-labor input, is the fixed input. So what is short run? Is just a time period in which, in terms of decision making, the firms treat capital as a fixed input and they can change quantity of labor. As compared to that, by long run we mean a time period in which all inputs are variable or all inputs can change. So both labor and capital will be treated as variable inputs. Now the best way to understand this is to look at a real world example. Suppose you are looking at a business called Pizza Hut located in your town, and on a weekly basis what the manager does or the owner does is decides how many workers to hire and when, but then it treats the building, the machines like ovens, furniture and all that as given, so they'll not try to change that part. The only thing they can vary is the number of workers. So they are making short-run decisions. When the management of Pizza Hut decides not just to vary the number of workers but could also change the location of the business outfit, or could also change the way the building looks, they may change the furniture or they may change ovens. So when they are making decisions like that, we consider this to be a long-run phenomena. So once again, in the short run, we treat at least one input as fixed, and in the long run, we treat all variables, all inputs as variable. Now consider the following example of a production function in the short run. The exact form of the production function is given by engineers or in technologists. And since we are looking at the short run phenomena, labor is the variable input which can change, capital, which represents non-labor input, is fixed. So here what you find in terms of this table, we are treating capital as fixed, so this amount doesn't change. There's 1 unit of capital all along. And the best way to visualize this kind of a table is, consider a small farmer who has a plot of land, and so the plot of land is fixed in terms of size. How much wheat it grows depends on now how many workers the farmer employs. Now, when the farmer employs no workers, nothing is produced on that plot of land. When the farmer employs one worker, how much output is produced on that plot of land? It is 5 units. When the farmer employs 2 workers instead of 1, the total output produced on that plot of land is 12. And in this way, this table is completed. So what this table gives us is how much output is produced when we use different amounts of labor on the same plot of land. And in the next slide, what we do is simply plot these points. So here is chart 1, where we have total output on the vertical axis and units of labor on the horizontal axis, and we plot the points that are contained in table 1, and we join them. So what we get is a curve, and this curve gives us the relationship between total output and labor. And so for obvious reasons, this curve is called total output or total product curve. And it's very easy to read this. When the firm or the farmer employs no workers, no output is produced. When the farmer employs 1 worker, 5 units of output is produced. When the farmer employs 2 workers, 12 units of output is produced. And this is how we would read the points on the total output curve. And what you find is, as we increase number of workers, the total output goes on increasing till the 7th worker. And then the contribution of the 8th worker, when we hire 8 workers, the total output produced falls from 42 to 40. Why does this happen? Think about it, and we'll get back to this point later. Look at another thing. So this curve contains information about total output produced when we vary number of workers. Now, based on this chart, we can also figure out how much output is produced by the first worker, and that is, let me write this down, first worker, it is 5 units of output. How much output is produced by the second worker? So let's write this, second worker. And how much output is produced by the second worker? It is 7. And in similar way, we can find out how much output is produced by the third worker. That will be 9. How much output is produced by the fourth worker, and so on. Another thing we can do on this chart is look at the following. When the farmer hires 1 worker, what is the average output produced per worker? It is 5 units. When the farmer hires 2 workers, what is the average output produced per worker? The total output produced is 12, and there are 2 workers, so the average output produced per worker is 6. When the farmer employs 3 workers, the total output produced by 3 workers is 21. And so what is the average output produced per worker? When the farmer uses 3 workers, it is 7 units. We'll get to these concepts of how much output is produced by the first, second, or third worker, or how much is the average output produced per worker when the farmer employs 1, 2, 3, or so on workers. And that is something we'll look at in the next slide. Thank you for your time.